So let's look at the problem number 5 of tutorial number 5. So in the figure we have to find the geodesic, that is the shortest path between 2 points A and B. Okay, those points are given. A is at r00 and B is at r pi by 2 h of cylindrical polar coordinate system. Now therefore we have to use this cylindrical polar coordinate system here. We have to find out this total length of this geodesic. How to find out this total length? Now what is a geodesic? Geodesic means the shortest path. So the way to find out that shortest path is, like, you know, from this A to B, this is your A and this is your B to B, there are infinitely many possible paths. So shortest path will be, how to find out the shortest path? Any path I can be found out by integrating this A to B ds. Integrating A to B into this ds. Where is this ds is your length element. So what will be the length element in the cylindrical polar coordinate system? That is equal to dr square r square d theta square plus dz square. This is your ds. Now since it is constrained over the cylinder, you see the small r equal to capital R and dr therefore equal to 0. This will reduce your problem to simply ds equal to under root of r square d theta square dz square. Okay, now integrating this from A to B will give you the any possible path on the surface of the cylinder. Now how will you find out the shortest path? By extremizing this integral. So to extremize this integral, once you extremize this integral, what you get is Euler-Lagrange equation. So let's find out that function or the Lagrangian here for this case. How to find out that? So substitute this ds here. So I will be equal to A to B ds, that is under root of r square plus r square d theta square plus dz square. Take d theta common like in the previous problem. A to B integral of r square plus z dash square raised to 1 by 2 d theta. Now what is the dash? The dash is defined as a dz upon d theta. This is similar to previous problem. So this I is an integral of A to B some function f z comma z dash comma theta into d theta. Now you got the Lagrangian. Here the Lagrangian is in the form of f. So therefore what will be the Euler-Lagrangian equation? D by d theta of del f upon del z dash minus del f upon del z equal to 0. Now find out what are these terms. So del f upon del z here is equal to 0 implies del f upon del z dash has to be equal to some constant k. So what is del f upon del z dash? Del f upon del z dash, if you calculate, you will find out z equal to z dash upon under root of r square plus z dash square. This is what you will get. This is equal to some k. Now you simplify it and find out what is z dash equal to. Z dash equal to k into r upon under root of 1 minus k square. This is your z dash implies del z upon dz upon d theta is equal to z dash is dz upon d theta is equal to k r upon k under root of 1 minus k square. This is what you have. Now integrate it, you will get z equal to k r upon under root of 1 minus k square theta plus c. This is what you get. Now fix the constants by applying the boundary values. What are the boundary values here? A and B. Those are the boundaries here. So at A what you have? At A, you know, theta is equal to 0, z is equal to 0, and x is equal, the r is at capital R. So that part we already applied here. So now this means C has to be equal to 0. So z equal to k r upon 1 minus k square under root is now your solution for z. C is equal to 0. One of the constant fixed. Now to fix second constant, we look at B. So at B we have z equal to h and theta equal to pi by 2. This is given. So z is equal to k r, oh sorry, there is a theta here, so k r into 1 minus k square under root theta is at pi by 2. Okay, now z is at h, so I can substitute h here, so take all the constants to other side, so 2h upon r is equal to k upon under root of 1 minus k square. This is what we have. So this entire term is a constant. So we got this value. Now let's substitute this value in the equation. What we have is this entire value we got. So what we'll get is z equal to 2h upon r into r theta. So r and r cancels. So this will become 2h theta. Oh sorry, there is a pi I am missing here. I have to take this pi also here. That will be pi coming here. So this is my z. So what will be z dash? Z dash will be equal to 2h upon pi. Okay. Now substitute this into our integral, that is integral of f z z dash theta into d theta, that is equal to a to b. This integral is from a to b. So what was this function? We had this function equal to d theta into under root of r square plus z dash square, right? Now the dash you have equal to 2h upon pi. Now substitute it there, so this will become a to b d theta r square plus 4 h square pi square. This is what you have. Now integrate it, it's along theta, so this integration will be from 0 to pi. So if you integrate this one, this will become r square plus 4h square pi square into pi by 2. So this is your total path. So you got the final answer. So thank you for watching the video. Let me know if there is any problem in the comment section. Thank you again.